Hypothesis testing of the population proportion using a binomial distribution. According to a genetic theory, 25% of plants should have red flowers, so that's your population proportion, 0.25. There's the random sample with 12 plants, so n is 12. The test statistic is 5. The significance level is 6%, and we're testing for greater than. So H0, the proportion P is 0.25, the null hypothesis, and H1, the alternative hypothesis, P is greater than 0.25, and here is the binomial distribution that we're going to use. So one of these x values will be our critical value, and the way to work out which of these x values is the critical value is to start off with the significance level, 6%, or as a probability 0.06. Because we're looking for an increase, then we need to do 1 minus this probability, so 1 minus 0.06, so 0.94. So then you look down the probabilities until you get to the first one that is greater than 0.94, which is this, but the 5 is not the critical value. It's always the next one along when you're looking for an increase here in H1. So if H1 says an increase, do 1 minus the significance level as a probability, so 1 minus 0.06, 0.94, look down the probabilities until you reach one that is more than the 0.94. That's the first one, that's where you stop, and it's always the next value along, which is the critical value. So these values are all in the critical region, values 6 or more, because this says more, and values 5 or less are in the acceptance region. Our test value is 5, so we're going to accept H0. But we need to give some evidence why we've selected 6 as our critical value. And here's the evidence. The probability of the rejection region, so Px greater than or equal to the critical value of 6, is 1 minus P less than or equal to 5. Less than or equal to 5 is here. And we have a probability here which should be less than or equal to the significance level, which it is. Because we have accepted H0, it's possible that a type 2 error was made. A type 2 error is the probability of accepting H0 given some new value for the population proportion. The accept H0 region is Px less than or equal to 5 from here. This is the accept H0 region. The new value of P is 0.45. A probability that x is less than or equal to 5. So 0.5269. This is the probability of making a type 2 error. To reduce type 2 errors, we can do one of two things. One way is to use a larger sample size. The alternative way is to make the acceptance region smaller. That means using a larger significance level to make the rejection region larger. Moving on to the probabilities method, so same example. We've got the same values as before, so up to here everything is the same. Because we're looking for an increase and the test value is 5, we need to calculate the probability that x is greater than or equal to 5. So px more than or equal to 5 is 1 minus less than or equal to 4. There's a probability for x less than or equal to 4. 1 minus that is 0.1576. So if this probability calculated is less than or equal to the significance level, we reject H0. The significance level is 6%, or 0.06. This probability is more than the significance level, so we accept H0. With this method, working out the probability of type 1 and type 2 errors is now awkward because we don't have a critical value calculated. We don't have the acceptance region, we don't have the rejection region. But reaching a basic conclusion is quicker than the critical values method.